Hello everyone, I'm Srinija and this is my colleague Anusha. We work as security software engineers at Splunk. We are here today to talk about a security practice that we have implemented at our organization and something that has worked for us, which is determining the exploitability of vulnerabilities using SBOM and VEX. Before getting into that, let's do a quick check. How many developers do we have in the audience? Can I see a show of hands? Thank you, awesome. Right, I'm guessing that like most of the developers, you prefer to use open source components or building everything from scratch, as it allows you to focus more on improving the quality of the product or improving the features of the product rather than reinventing the wheel, right? However, using these open source components bring along vulnerabilities. But that doesn't mean that you should stop using open source. We can always control these using some gatekeeping measures. For example, using software composition analysis as software bill of materials and vulnerability exploitability exchange. SCA is basically a process which detects open source components and third-party components that are being used in a software product. With the regular analysis, one is aware of all the components that are being consumed by the product. Keeping track of these components is what SBOM is all about. In short, SBOM is a document of list of all the open source components, their versions, and their licenses. With this list in hand, one can easily determine whether a vulnerable component is being used in their product. And that's exactly when VEX comes into the picture, which Anusha will talk about in a while. This is our scanning workflow back in 2022, where with the shift left mechanism, scanning was integrated with the CI/CD. So our developers would push their changes to the central code repository, and the changes were scanned with the help of CI/CD, and the scan results were shared with product security teams for the review, and the review results were sent to the developers, where the developers would do the needful. This was a continuous process. This was a pretty much self-service and developer-friendly process. Especially, the developers had a privilege to customize the configuration, scan configuration as per their product needs. Like I mentioned, as it was a shift-left mechanism, it was a product team's responsibility to ensure this code scanning is done, and the product security team was also responsible for reviewing the scan results. It was a happy-go path until we wanted the product-wide vulnerability information, and it was quite a task for product security team to collect this information. So we wanted to address this gap of not having collective data at one place. So we wanted to switch towards a centralized model. Then we started building asset inventory and centralized scan platform. So when the executive order for SBOM has released, which mandates that every product that is being used by the federal government should have a SBOM associated with it, we took it as an opportunity to build the asset inventory. We have highlighted the importance of asset inventory management, especially with the product teams, to have them on board with us. We started mapping the code repositories and the build artifacts with the products. For the ease of purpose, we had to do some internal tooling to collect this information from the product teams to build the inventory, but it was necessary. So CTS portal is one of them, where we have an option, we provide an option to the developers to offboard their code repositories, artifacts for scanning. Along with that, we ask for some more details, such as whom should the tickets get assigned to, which branches would they like the scans to run on, and which all severities would they like tickets for, and so on. Once the user submits this form, this data gets saved in our inventory. So the key benefits that we got with this asset inventory management is it's quite scalable, so we could add any number of code repositories and artifacts without any issue. And we finally got our product level telemetry. However, the challenges were operational costs and also keeping the product inventory data up to date. So simultaneously, we started building a centralized system. So the main goal was to build a system which is user-friendly and enables easy scan and also requires less involvement from the product teams. We wanted to build a system that could perform end-to-end operations, right from scanning the repository to processing the scan results, to creating the tickets, to notifying the owners about the tickets which got created for the ones found by the scans. 2,000 years later, just kidding, we did it a little sooner. So this is how our centralized scanning system looks like today. So our main program gets the product data from asset inventory, and it requests the central scan platform to run scans on a certain repository, and then central scan platform will initiate these scans, get the scan results back from the tools, and sends these results back to the main program. And the main program finally processes these results and maps the right owners and stores these data in our central storage. Oh, sorry. Yeah. So the main advantage that we got by building the asset inventory and centralized scan system is SBOM generator, wherein we want, which we were looking for. So we had an option to generate the SBOMs very quickly and easily. So we had the product data right with our asset inventory, and we had the scan results ready with the tools. All we had to do is map this data accordingly, and with little bit of formatting, our SBOMs were ready to be shipped. So the other advantage we got with this is Security Central, which is a dashboard of metrics. So we could see the distribution of findings with respect to scan type, with respect to severity, and we could also see the count of tickets that got created with each type. So we scanned different types of scans, which is like SaaS, OSS, threat modeling, and then credential management, and then so on. And we could also see a detailed view of these tickets. For example, we can filter the list based on the assignee, and then we can also filter with respect to the severity. These are furthermore insights, wherein we have an option to filter with respect to product or the employee. And these are some trends and patterns that we have seen over the past 3 months, wherein the tickets that were, the average time we have taken to close certain tickets. Oh, they said managing video is easier in demos, but it doesn't look like that. All right, yeah. So like I said, these are the trends and patterns, and we could also see the distribution of findings with respect to severity. And these are some of the dashboards that we have based on the top 3 vulnerabilities, product vulnerabilities that we have seen organization-wide, and some infrastructure vulnerabilities organization-wide. So this is another important feature of the Security Central, where it allows to filter based on a CVE. So let's say there's a potential risk CVE out there, like Log4j. We can quickly go find the CV, provide that CV here, and see which all products are using that certain vulnerable component which is associated with the CVE, and we can quickly get the results. We could only build this dashboard and metrics only because we had the asset inventory and the centralized scan system in place. Well, I have covered the good side of the part. Now Anisha will cover the dark side.
Thank you. Yeah, so we don't want to paint like a rosy picture of the solution. So yes, like we are all aware that tools do generate a flood of vulnerabilities. With that, if we are ticketing every one of them, like there is a flood of tickets. And the bigger issue is that not all of them are valid and actionable. So in an internal analysis, we've discovered that like greater than 26% of our vulnerabilities that are found by these tools, they're either not exploitable or not actionable. This is like 1/4 of our findings. So yeah, we like worked really hard to like build all of this tooling. But if it's just causing developer turmoil, then like what's the point of building all of this? So that's where we realized that it's on us to kind of figure out what are these 25% of issues and how do we like remediate them and let developers do their jobs without interrupting them. And we also noticed that like the CV count just keeps increasing every year. There are more findings every year. So this problem is here to stay. If not, it's going to get worse. So how do we handle this flood of vulnerabilities and still try to enhance developer experience? That is where exploitability comes into picture. So exploitability is the likelihood of a vulnerability being exploited. So currently exploitability has picked up a lot just because of the problem that we just discussed. So we can determine exploitability in like 3 possible ways. First one, look up public sources. There's a lot of data. Whenever a new CV comes out, there are databases that try to determine how it can be exploitable and what's the exploitability factor of a vulnerability. Second one is perform reachability analysis. This is something that a lot of SEA tools have picked up recently. That is, they try to determine if the exploitable code path is actually reachable in the product. Like, is the product actually using the vulnerable function? Otherwise, you can reduce like the exploitability factor of it. The third option is just like ask the developers themselves. That's what we are going to focus on. Vulnerability exploitability exchange VEX. So a VEX statement indicates like the state of software product or a component with respect to the vulnerability. In easy terms, it's basically trying to determine like exploitability and communicate that information. The VEX statement tries to do that. So what is VEX? Like, how is it different from any security advisories that companies publish? So A, VEX is machine readable. And B, it complements well with the SBOM structure that we can like embed VEX statements into existing SBOMs. And C, it's like the whole idea of VEX is that we want to like improve and support greater automation and kind of standardize like vulnerability discovery and how do we communicate that information. So if we look at SBOM as like an inventory of products, we can easily supplement VEX information in that and say, hey, if these components have vulnerabilities, we're also providing information on what we are doing to act on them. So we are currently using the original VEX recommended statuses, which is not affected, affected, fixed, and under investigation. So when we started generating SBOMs, it was easy, like get product inventory, get scanning tools, map all of them, and then we'll get our SBOMs. But then when we decided to generate VEX, we realized that we need to start tracking remediation. And not just track remediation, but tie it back to our product inventory again. And that posed like a quick challenge that we need to now mandate VEX information, and we need to fetch that information to generate VEX statements. The next quick thing that we realized is that we do need developer feedback. Yes, tools are amazing. They give us a lot of info, but they also give us like a lot of false positives and negatives. So we cannot purely rely on like tool feedback to get the information that we need. So we need a way to like fetch and like ask the developers like, hey, like you have the final say, can you let us know like how are you using it? And we need a way and a mechanism to get that information in an automated fashion. So, and like the developers know their build systems best. So, which is why we need that feedback. Yeah. So now that we've established that we need to collect this information, there were multiple options in front of us, like use existing tools to collect this information, maybe build your own tool or buy a new tool to get this information, or use the issue tracking systems to collect this information. And we went with a very interesting choice of using our issue tracking systems to collect this information. This is why this has worked for us. Issue track, we can use it like an abstraction layer on top of our security scanning suite. We don't want our developers to like run behind all the tools that we are using and like go set this information. So we decided to like use it as an abstraction layer. And as we said, we had to mandate VEX information. So the issue tracking systems gave us an opportunity to do that. Like they can't close an issue without like setting the VEX details. And why we didn't go with a new solution and we decided to use this is we want to minimize the learning curve. Like teams already use issue management systems. So it was easy for us to just like go and add on to it, and there was like no added learning curve. And once a generic issue template was agreed upon with our engineering teams, it made our lives easier because we could integrate more tooling, and all we had to do was adhere to that template and provide as much information as possible. So here are some advantages that we got by using this. A clear answer on exploitability. That's what we wanted to get in the first place. And it also comes with like developer ownership and audit trail. So like we could determine which developer owns a component if it's coming into our ecosystem. And that was very essential. And also the component usage. The advantage too is VEX generation. That's why we started all of this. We could start generating VEX statements automatically with all the data that we received. How does it work is that Srinija just described how we were generating SBOMs. But now with the issue tracker in place, we were able to start collecting remediation information. And then now we have a database table where we store all of that information. And all we had to do is correlate that data back to our product inventory. And final result is VEX embedded SBOMs. Before I go to advantage 3, like going back to the original problem that we just described, like there are still those 25% issues that are not actionable. And what are we doing about that? And trust me, like we needed to get and implement all of this to even act on that problem because we didn't have the data before. So now what we are doing is we started collecting remediation data. And now with that, we are able to build context around the packages that we use, around the issues that we have. And that context is helping us determine like the final solution that we can do. And like if we want to remediate an issue automatically, if we want to make decisions in place of developers, we are trying to use that data to make that determination. So how are we building context around these packages? We are using 2 sources. First one is external sources. Like whenever an issue comes into our ecosystem, we are like, hey, let's use external sources. Let's look up the internet and see, and if an issue, if there's no fix available, then we are automatically taking it in and then we are closing the issue. And internal sources, this is where all the data comes into picture. Now with all the remediation data that we are collecting, we are kind of building patterns. And with those patterns, we are codifying like what we have as an institutional knowledge. And then we are like presenting actionable output. So with all the data as well, now we are able to like generate dependency graphs, and now we have enough data about an issue internally that we can say confidently that, hey, like this is a false positive because we've seen it enough number of times. So yeah, the first example is exactly what I just described, where we saw an issue like multiple times, and then we are like, hey, we are closing this issue because we've seen it multiple times. We have certain factors that we use to evaluate this. We've seen it multiple number of times. Someone said it's a false positive, and we can like trust that source. So we will close all future occurrences of that issue. And that way we are trying to reduce like that debt that is generated. And we also said it's going to be tool agnostic. So, why is it tool agnostic? Because this is institutional knowledge. This is very specific to your company. So if we build it in a tool agnostic way, then it is scalable. Like tomorrow you can integrate 100 tools, but you'll still have this information that will be completely tool agnostic, and it'll still work for your remediation. The second example is closing ticket because no fix available. That's an example of the first external sources data source. An additional benefit that we got with this is smart insights. As product security, with all the data that we are collecting, now we have a bird's eye view of all the security issues that we are seeing. And most of the times, like product teams are working in their own silos, and sometimes they're working on the same issue because it's a common CVE that's found. So what we are trying to do is we are trying to provide insights to those teams and be like, hey, another team is working on a similar issue. Maybe you can just look it up or talk to them and see how you can remediate it. And with Smart Insights, what our key goal is that we want to help each other. So that's what we are trying to do. And before I head into future scope, like we don't want to promote this as a gold standard solution. What we are trying to do is, like, when the problem was presented to us, we didn't have a lot of resources available, so we did a lot of trial and error approach, and we are presenting like what worked for us. But we really want to know like how everyone else in the industry is tackling these challenges. And with that, our future scope is that we want to use agentic AI. Like I said context, I said a lot of data in, so I think it makes a great use case for agentic AI, where we want to feed all of this data in and all the context that we are building, and finally determine if a component is exploitable or not in our product. And with that, we also want to improve insights accuracy and detail. Another goal that we have is to generate an open source VEX statements along with our product releases. Right now, we just give it to our customers upon request, but the idea is to just ship VEX embedded SBOMs with our product releases. And the final goal is open sourcing our centralized scan system, our ticketing dashboard system, everything that we can, that we've built in a tool agnostic way. And the idea is to, like, if it can help someone who's facing similar challenges, that'll be great. So yeah, quick shout out to our team, because we are representing all of their work here. And thank you so much for the opportunity.